This assignment is assignment 12 in test prep and deals with a very important topic, that of right triangle trig. And if you can remember how to set up the triangle to get it right triangle trig ready, you're not going to struggle with most problems. Of course, there are problems um, on the difficult side dealing with this pretty simple concept of right triangle trig. But I'm going to show you how to use it to solve for sides, how to use it to solve for angles, and then just maybe a problem or two in an applied setting. Um, when do you use it? When you have two sides missing or two angles missing. So if you have one side missing, that's the Pythagorean theorem. And that's a different topic. It still belongs to this, and it's important that you know the Pythagorean theorem. It's just a different topic. And angle sum, which of course should always be foremost in your mind when you're dealing with any triangle. 3 angles add to 180. So how is it that we actually use right triangle trig? So let's say we're looking at a problem like number 4. And so I have problem 1 written out there already, but I want to do a few here live so you can see actually how to begin. So we want to figure out what x is. We're missing 2 sides, this leg and the hypotenuse. So that means I start the right triangle trig process. You must do this. I just think it's so helpful. Very few people can actually see what to do just with this alone. Select the angle and then label the sides as they pertain to the angle that you've selected. So I labeled the adjacent side, the opposite side. By the way, they make the right angle, and the adjacent side is a side in the angle that you picked. So the A and the H are always connected to the angle you pick, with the A making the right angle. Now look at what 2 sides actually have the labels on them. The O and the A. Well, that means that it's the tangent ratio, the O and the A. Tangent equals opposite over adjacent. Cosine equals cosine of the chosen angle equals adjacent side over the hypotenuse. Sine of the chosen angle equals the opposite side. So that's what we're going to use to set this up. And so literally, this is what I'm going to write down. Tangent of 42 over 1 equals O divided by A. How do we know it's 5 over x? Because it's O divided by A. That's the tangent ratio. And then what? It's a cross product and a division. Now, not all the time is there a division. So x times tangent 42, it depends on where x is, equals 5. So that is that first step, cross product, and then divide both sides by tangent 42. So x equals 5, I'll just kind of write it like this, over tangent 42. And it's important that you do this work because a lot of times the test will have the choices in terms of, and make sure I'm in degree mode. By the way, make sure you're in degree mode when you do this. Oh my, that's a picky thing. So 5 divided by tangent of 42, 5.6. And that's essentially how you do any of these, but you have to focus on what 2 sides have the labels. So notice back here in the sine one that I had pre-done, the opposite and the hypotenuse had the 6 and the x. But to know what 2 sides have the labels, you have to put the A, the O, and the H in there based on the angle that you pick. Now you can pick the 30 or the 60 over here, but you can't pick the 90. Illegal. It's got to be one of the acute angles that you pick. All right, one more of these, and we'll move forward. Number 8. So number 8, I chose 63. Now what two sides have the labels, the A and the H? That's how you tell what one. Well, what is the A and the H? That's cosine. So you're going to write that out. Cosine of 63, I'm going to put it over 1 because we got to do a cross product, equals adjacent over hypotenuse. Now, I always get the question, is x ever on the bottom? Yes, it is, but you don't worry about it. You worry about writing the ratio out correctly. So cross product, and then you would divide both sides by cosine 63, and you would get 70 over cosine of 63, which is basically going to give you the 154.2. But make sure that your calculator is in degree mode before you start. All right, that's trig to get a side. It's probably good to write down the Sohcahtoa when you come to Sohcahtoa, when you come to a trig problem. Have that memorized as an acronym. So here's the problem in finding an angle. So we want angle X, so that's the one we're going to choose. And then from there, you label the adjacent, the hypotenuse, the opposite. Notice the two sides that have the labels, opposite and hypotenuse. So that's a sine ratio. The problem is the x is now in the parentheses where the angle goes. Sine x equals 8 over 10. Then how do we get this? X is sine inverse. That means that you take the sine inverse of both sides. And then the sine inverse, I'm squeezing it in here, of 8/10. Well, the sine inverse cancels with the sine. And then we're left with sine inverse of 8/10. So that's always going to work like that. If it's tangent x, we take tangent inverse. If it's cosine x, we take cosine inverse. Okay, and let's do a tangent one because those are ones that are most popular. So adjacent, hypotenuse, opposite. So notice the two sides that have the labels here and here. That is Oa, Toa. So it is tangent. So we have tangent of x equals 7 over 8. Opposite over adjacent. That's how you know which one goes where. Oa. It's O divided by A. Okay, so x, you're going to do tangent inverse on both sides. So x is going to be tangent inverse of 7/8. And when you do that, lo and behold, you'll get, so you got to use your second function key, hit the tangent key. Anytime you do an inverse trig calculation, you will get you're getting an angle, 41.2. So you use trig to get a side or trig to get an angle when you're missing 2. So note that we were missing both of these angles. This one's 41.2 and this one is 90 minus 41.2, and we knew the 90 degrees. By the way, you do not use this if the triangle you're working on is not a right triangle. So don't think this applies to every triangle. This only applies to right triangles. You'll learn, if you go beyond Algebra 2, what is called the law of sines and law of cosines. That solves any triangle. That's a little bit more involved though. All right, so the very same thing applies to problems that are applications. And let me talk about the ladder one here. The ladder problems are so famous. So here's your wall. Here's the ladder. And here's the distance from the wall to the base of the ladder. So 4 meter ladder, here's the height of the wall, angle it makes. So how far up? Sometimes it asks for this length, but you have to know what it is that these things represent. So note you have the O and the H with the X and the 4. Sometimes you have to put the X in. Here you did. You had to set the whole thing up. So note that sometimes you have to put the X down by the side that you want to solve for, and then you'll know, okay, what two sides have the labels. So this is a sine of 75. I'll put that over 1 equals X over 4. Now, most of the time in word problems, it's tangent. So like literally on almost all the rest of these, it's a tangent function. So X is 4 times sine 75. So see on this one, we did not have to divide. So it just depends on where X is. And make sure that you don't make this mistake. This absolutely drives me crazy. That is not what you do. Do not do that. If you're going to do the sine of 75 first, you have to close it up, 3.9, or else you're doing sine of 75 times 4, which is some huge angle. Do not do that. That just drives me crazy. Okay, and you see here another ladder problem. Of course, when you get one side, so let me just, what's the farthest up a vertical wall? So 28.2, so I'll write that down. Once you know two sides, you then can use the Pythagorean theorem. And let me just talk about that. So you trace the right angle. That's your a squared plus b squared. So figure this out, it's 28.2. Now trace the right angle. That's your a squared plus b squared all the time. And then you're going to subtract that over. So 30 squared minus 28.2 squared, 104.76. And then you're going to square root that, excuse me. And that is 10.2, as you see. So that is the Pythagorean theorem. If you wish to employ that, that is also part of right triangle. So that's a right triangle trig. My advice is have you write this down. Not all questions are this easy over right triangle trig. Some of them are, the applications can be a little bit crazy, but this is the basic structure of what you'll get with right triangle trig.